You ready? Okay. Good afternoon. Welcome to the panel session on Circular Economy Asia Pacific Conference, which is jointly organized by Professor Sudipta Seal, myself, Professor Sriram Ramakrishna. He comes from the USA, and myself representing Singapore. So this is a binational first conference on circular economy. This is a 3-day event supported by both National Science Foundation USA and Singapore, and also several other organizations. This is a 3-day meeting. We had a format of keynote presentations, invited presentations, and also we have a highly esteemed panel session. So right now what you are going to witness is a panel discussion which is aimed at circular economy opportunities, the gaps, with a focus on what could be the potentially interesting things that are happening in the world related to the circular economy for its progress. Also, any education-related activities, also the activities related to standardization, plus some other policy and regulations, plus business practices. So we have a panel with members drawn from the industry, the universities, as well as the policymakers, and they have combined together more than 100 years of circular economy related experience. They're very passionate individuals in their own way. So welcome to this panel discussion on circular economy. I would like to invite the panel members to self-introduce about 1 or 2 minutes. After that, we will go towards more detailed, engaging discussions. Could I invite Mark?
Okay, thanks very much, Professor Sriram. Hello, everyone. So I will be quite open and honest with you as well. I need to leave a bit early today, so you'll just see me disappear off the stage at some point. So anyway, so my name's Mark Allen. I am a chemical engineer. I've been sort of postgraduate chemical engineer for a bit over 20 years now. For the last 11 years, I've specialized in the area of climate change and sustainability. And right now I have a Singapore-based business called Engico, and I'm the director of that company. And what that company does is helps businesses understand exposure to climate change risk and develop climate change strategies. So I'm quite focused on climate change as a concept. Circular economy does feed into that, and I will explain that a little bit later, but it's all about circular economy and circularity as a means to achieving climate change goals and reducing consumption and reliance on raw materials, et cetera, et cetera. Another hat I wear is Singapore has a National Mirror Committee for the ISO standards development on circular economy, so I'm currently chairing that committee, co-chair with Delson Chung from the NEA. And I will talk about both of those things in a little while.
Thank you.
Welcome, everybody. I'm David Gruel. I'm currently the Department Chair of Industrial Manufacturing Engineering at North Dakota State University in Fargo, North Dakota. Joined NDSU about a year ago. Prior to that, I was at Iowa State as a professor in the Department of Agricultural and Biosystems Engineering. While I was there, I was the founder and currently the director of CB Squared. It's a National Science Foundation Center on bioplastics and biocomposites. It has 4 different sites: NDSU, Washington State out in Pullman, Iowa State in Ames, and then UGA in Athens, Georgia. Also did a lot of work in the area of biofuels over the years, and prior to coming to Iowa State, I was at Emerson Electric for 14 years, and where I did a lot of work in the area of diffractive optics, lasers, and holography.
Okay, good afternoon, everyone. My name is Adrian Kwa, and currently an associate professor at James Cook University. At James Cook University, we started a circular economy and sustainability program where we look at the circular economy from a very macro perspective, whilst integrating the micro perspective from a materials point of view, from a bio-circular point of view, from a consumer point of view in terms of the consumer's awareness and acceptance of circular economy business practice. In my previous life, I was a mechanical engineer, so I used to work in the Ministry of the Environment, where I was very much into sustainability, water resources issue. Right now, I'm in a business school, and I teach students on the grander issue of sustainability. And for the last 5 years or so, I've been very much involved in circular economy business practices. Thank you.
Hello, I'm Carol Handwerker, Professor of Materials Science and Engineering at Purdue University. I also have an appointment in Environmental and Ecological Engineering, also at Purdue. I've been involved in environmental engineering and issues since I was in high school. I did water pollution research with respect to effluents in the Mississippi River. Once I went to college, I actually rented the apartment from Dennis and Dana Meadows in 1972 as they went to go write the 1972 pioneering work called Limits to Growth, and I received the copy of that when they came back after being gone to Europe for the summer. So I've been involved in these kinds of issues for quite a long time. I was at NIST for 21 years, and I helped make a major transition in the electronics industry, going from lead-containing solders in electronics to lead-free, and I helped that global transition. Since then, for the last 14 years, I've been at Purdue, and so we've had a number of major programs. One was an IGERT, an Integrated Graduate Education and Research Traineeship in Sustainable Electronics. I've been involved with industry consortia for the last 25 years, and I helped lead a major industry consortium in developing a circular economy for hard disk drives. So I'm very delighted to be here.
Thank you. I'm Terry Collins. I'm the Teresa Hines Professor of Green Chemistry and the Director of the Institute for Green Science at Carnegie Mellon University. I've been teaching chemistry and sustainability now for 25 years. I think the first course in chemistry in this area, and I've learned a very great deal about the fact that chemistry is not how I ever imagined it when I was quite a bit younger. The main reason is that every day, everywhere, chemicals that we have in our homes and in our products and pretty much everywhere interfere with the hormonal control of development. The net result is that we are seeing impacts in the human population and in biodiverse populations like you cannot believe that are exceptionally worrying. As we move towards a circular economy, I am deeply concerned that we do it properly, that we do it the economy that we want to build.
Good afternoon. My name is Brijendra Mishra. I'm a graduate of the Indian Institute of Technology from Kharagpur, where your co-chair was a kid when I graduated. And after that, I went to the Colorado School of Mines, got my degrees from University of Minnesota. And at Colorado School of Mines, I served for 25 years. And now I have retired from there, and I'm a University Emeritus Professor at School of Mines. So now I have a full-time job at the Worcester Polytechnic Institute. So what that means is I have retired from CSM and I have a full-time job, meaning I am double dipping, but that's legal. And at Worcester Polytechnic Institute, I wear several hats. I'm the director of the Manufacturing and Materials Engineering program. I'm also the director for the Metal Processing Institute, which is the largest in North America single university industry-supported research center with over 90 corporate members. And then I also direct the National Science Foundation IUCRC, the Industry University Cooperative Research Center on resource recovery and recycling. Probably one of the unique ones that NSF has. It has close to 70 of these centers. But in this area, perhaps the only one that they are funding. So I'm a trained process metallurgist, and I have been in this area for pretty much my entire career. and have been working with technology development for resource recovery. Also have worked a lot in the area of corrosion, and probably when we talk again or come to the second round of speaking, I'll try to link how corrosion is an important aspect when we talk about circular economy and sustainability.
I'm Ashley White. I'm the Director of Communications for the Advanced Light Source, which is a synchrotron light source at Lawrence Berkeley National Laboratory. That's my day job. How I got into that field is a little bit of an unusual path. So I started out in materials science research field. I got my PhD in postdoc and then transitioned into communications via policy. So I served as an education policy advisor in the US Congress and then worked on sustainability initiatives starting with a position at the National Science Foundation. So I've been working in the sustainability arena for about a decade now. And I, in particular, got involved with the Materials Research Society working on sustainability initiatives about 7 or 8 years ago. And I currently chair MRS's Focus on Sustainability subcommittee and lead some of the efforts around sustainability and also work with them on advocacy and policy as well.
Thank you. My name is Martin Stavenhagen. I'm a circular economy and climate innovation consultant here in Singapore. Thank you very much for the invitation, and it's a pleasure to sit with such an esteemed group of fellow researchers, thinkers, and doers as well. I founded my company basically not that long after the Paris Agreement because I thought that circular economy would be one way to have a chance of reaching the 2030 climate goals, as well as the SDGs, the Sustainable Development Goals. And if those should be reached by 2030, then what happens the next 2 years will definitely set the track for that. So I work with policymakers, businesses, startups, with system innovation tools to help to find more sustainable solutions. And before that, I worked for the National University of Singapore, both at the Lee Kuan Yew School of Public Policy and the Institute of Water Policy as well.
Okay, thank you, Martin. Well, you agree with me that we have a fantastic panel here, and they convince themselves over the time through their careers why circular economy is important. They need to play a role in circular economy in terms of promoting research, innovation, policy, as well as implementation. So the way we're going to go forward for the rest of the panel discussion, I now invite each panel member to talk about 5 minutes about why circular economy is very important to them, or why they think that is very important. And perhaps they could also say what are the things that must be pursued for circular economy to happen much more strongly, much more visibly. So I like to start again with the same sequence with Mark Allen. Then after that, other speakers would talk to us about 5 minutes. Then after that, we go through the questioning process. Mark, please tell us about 5 minutes, what this means to you, and what would you like to see happen?
Sure. Okay, so there's a couple of parts of that question which I'll address. So first of all, as I alluded to in my introduction, so my particular focus is climate change. I see climate change as this huge existential issue that needs a concerted effort by governments, business, and civil society to achieve the overall goals. Because there is a lot to do in a very small amount of time. I don't think I can stress that enough, right? So circular economy and circular economy principles feed into that as part of the solutions. So right now we've got this big problem. We're running up into all these, well past a lot of these planetary boundaries, and there's a lot of, unnecessary consumption as well, and just getting new virgin materials every time we need products because they've not been designed correctly in the first place to be able to be taken apart or to be able to be reused or remanufactured or recycled at the end of life. And we're actually doing a really terrible job at closing all of those loops right now as humanity. So, and the more we rely on extracting stuff from the environment, virgin materials, because let's be frank, everything that exists that we have has either been grown or mined in some way. So all energy systems, all things come from the environment, ultimately. So the more we can reduce our reliance on extracting this virgin material, which comes with an energy and therefore emissions penalty today, the better off we'll be overall. So I see that as a big solution and a good way to try and get to our goals, because it's going to be pretty difficult otherwise. So then what can be done about it? Now, I mentioned earlier, the other hat I wear is as the chair of the National Mirror Committee for Circular Economy Standards. So basically, the ISO, International Standards Organization, they are developing a set of circular economy standards and guidelines and touching on a whole lot of different areas. Now, this is part of the way we can move to something that's more circular, or an economy that's more circular. Because ultimately, when we get there, we won't need these standards because it'll just be a transformation to the economy from this linear economy to a new model that is the circular economy, and you don't need standards to govern that because it just is, it's just happening. But we need something to sort of push us along that way. So the ISO has people from all over the world. There's 55 participating members, all of which are individual nations participating in this, and Singapore, in their wisdom, has chosen to be one of those members also and participates in the development of these standards. So I think developing these standards and guidelines to provide a framework by which businesses, companies, etc., can change their business models and move to something more circular, I think, is key to this. The other thing that I think is key is a little bit of a policy push. So the linear economy is cheap and easy, and it works really well, and it's been working really well for some time. The policy push is there to address this sort of market failure to try and get to that new model ultimately. So it's a mix of regulatory push as well as providing standards and frameworks, etc. Yeah. So in the ISO discussions we're having, and I'll just be clear as well, the ISO technical committee is right at the beginning. There's been one meeting, we've been working for like 3 months on this work to develop the standards. So right now the focus is about developing these frameworks and setting the definitions and looking at how we even measure circularity, because how do you say whether a company or a product or something is circular or not if you don't even know what metric you're using to measure that? How do you calculate % circular? We don't know yet. And looking at setting up the guidelines and adapting some of the guidelines like the British standards that have been used already to get to that point. So yeah, so like I said, I do see it as an important part of the future. I do see that the world will move to a circular economy out of necessity more than anything else. I think, as I said, we're already beyond a lot of limits of what the planet can take right now. So out of necessity, we have to transform the economy that we all exist in. Right. And I will say as well, I do see a lot of conflation of circular economy with recycling. So just to get this point across, I think recycling is the last loop that we should be thinking about. It should be definitely redesign of products for remanufacture, reuse, right to repair laws. All of these things sort of fit into a circular economy framework. So, and that's a lot of what the ISO standards are working on as well currently, to provide that guidance. All right.
Thank you, Mark.
Good job, Mark. That's going to be hard to follow. What's the circular economy mean to me? It's actually just one little tool of many tools that we need to use in order to move forward. every generation comes out and said, we're going to leave the planet in a better state than when we found it. And we're not doing a very good job of that. When we look at, every barrel of oil we pull out of the earth, out of this single planet, we don't have any other options, not for a long, long time, and maybe never. Every time we pull that out, 2/3 of that goes to fuel. And so 2/3 of that turns into CO2 just to move us around. And I'm guilty of that, right? I was on, a 20-some-hour flight to come here from the United States. I'm part of the problem. And so I'm not doing a very good job of walking the talk, not doing what I preach. Now, that's true for faculty, for professors. We never do what we preach. We just come up and start talking. So they're just, a good model of that. But the circular economy is part of that solution, is trying to reduce, to reuse, and so on. And I'm not convinced that maybe that standards are going to be the way to do it or policies are going to be the way to do it. I think that to make this happen, we have to start on education. Now, as a college professor, by the time I get the students, their mindset is already defined. Their mindset of, what's good and what's bad, and I can burn this, I cannot burn that, and so on, that's already been so well entrenched by their family, their environment, and what they've experienced in their young lives. And so I think it's important for us to start looking at trying to help educate the young ones. And I mean really young, 5, 6 years old. When you look at the number of women that go into STEM, it's fairly high, but then it drops off fairly quickly after they graduate. And we just don't do a good job of cultivating this atmosphere and making sure that we're teaching the right things and making it all happen. So I think it's a good idea that we try to really leave what our parents said to us, that they wanted to leave the planet in a better shape than we did. And that could be greenhouse gases. That could be the plastics that we see floating in the oceans, or the chemicals that we see leaching out of plastics, or the lead that's in our water all over the United States. We need to do a better job of this. And I think the circular economy is a part of that solution. It's not the solution. It is a solution, but not the overall. There has to be a lot more of that.
Thank you, David.
Yes, I do agree with the earlier two speakers. And I see the circular economy as a grand macro model, where we use micro solutions to solve the grand problem. Problems are created by men, usually. Let's take an example of a wind farm. Now, wind farm is supposed to provide green, renewable energy, right? So for the last 20 years, there is a proliferation of wind farms around the world, especially in China, where capacity is growing, doubling every year since 2006. So 20% of our renewable energy needs, or our global energy needs, are supposed to be solved by wind farms. But by the year, in a couple of years' time, 18% of our global energy consumption is from wind farms. But what has wind farms created? Well, over the last 20 years, because of newer technology, newer materials, a lot of broken blades are lying on the hilltops in China. In fact, there is actually a hill that is called the Composite Hill, because all the blades the size of an aircraft wing are lying on the hilltops. So, what do we need to do? We need to look into engineering solutions to recover the composites, because these composites are not biodegradable. They will sit there for the next 50 years, the same shape and the same form. Now, some engineers have proposed making them into park benches, non-structural usage. But how many park benches do we need in the world today? Right? So through engineering, through materials engineering, we can use thermopyrolysis, for example, to recover the carbon fiber, which are very expensive materials. The virgin carbon fiber costs about 30 euros per kilo, right? The recovered carbon fiber can be sold at about 15 euros per kilo. And, if the recovery process is good, these have the same mechanical properties as a virgin carbon fiber. So we need to look into micro solutions, to solve this bigger problem, to address this bigger problem. And in doing so, recover resources, precious resources such as carbon fiber, precious resources such as the rare earth, so that we don't have to continuously mine from the earth such resources. So I see the circular economy that has started in the last 10, 15 years as a grand solution to solving the problems created by humans. Thank you.
Thank you, Adrian. Carol?
So when I think of the circular economy, I don't think of a grand solution. I think of a product. It is that product that we've got to create the circular economy for. All of those different circles that we see in the Ellen MacArthur Foundation schematic, that's where I guess the devil is in the details. The other thing that I see when I look at the circular economy and that product is that I see all of the people, the communities, the places in the world that have been impacted by the production, the reuse, the use of that product. It's something that I benefited from by working with anthropologists. There's something called behavioral anthropology, where they take a product, some object, and they say, this really embodies everybody that ever touched it. And to me, that gives us a different view, sort of the life cycle assessment, and also the opportunities, the trade-offs involved in creating a circular economy, because it embodies the people, not just the processes or the water. I mean, it's all part of that, but it's ultimately the people and the environment. So by looking at it that way, it's forced me to look at something as trivial as what's called the IPAT equation in a much more critical way. The IPAT equation is that the impact of a group of people is equal to the population, the impact for that particular population, and then there's something that we'll get to later. It's a term that technology makes us better or worse. But if we just take those two, it's forced me to look at the IPAT equation in a much more critical way. Who's bearing the costs? We talk about externalizing costs. Well, there are people externalizing the costs. When we're doing these LCAs, it usually ain't us that's really being affected. So it's forcing me to actually decompose the people, the communities, and the burdens, the environmental, human health burdens, and economic benefits that accrue. So to me, that's something important in the circular economy that I think if we well, for those of us who are engineers, if we look at it as a thing and processes and inflows and outflows, that we really miss the importance of this really more globally and then down to individuals. And the last thing is the Brundtland definition is not what we've had people show in the last 2 days. The Brundtland definition, yes, it says protecting the environment for generations, but they forget the two other points that go below that. One is paying a special attention to the world's poor who are bearing most of the costs and who are not accruing any of the benefits. And the other is paying attention to the social and the technological situation as well. So the Brundtland definition, I think, for us to be creating a real circular economy, we have to take the full definition and we have to consider these other parts than the people part of the people, planet, profits. And otherwise, we're fooling ourselves. And the shifting of the burdens can be even much worse.
Thank you, Carol. Terry?
Thank you very much. Thank you, Carol. I really do agree about what you said about the Brundtland definition. Building a circular economy, building any kind of economy for the future is really about developing a competence with respect to sustainability that we don't have. I mean, you can see right away that with so-called hundreds of so-called great universities in action, that it's somewhat amazing that we are staring down the barrel of the existential threat of climate change with rampant denial. And at the same time, we have another existential threat that hardly anyone knows about, which is the impact of chemicals that we chemists make and distribute that end up expressing developmental toxicities, changing the development of living things at extraordinarily low doses, parts per trillion to low parts per billion. The science is absolutely categorical. There is no question about it. It is almost certainly related to the fact that we have falling sperm counts in Western man where we have good data. We've lost nearly 60% of the mean sperm count value since 1973 to 2017. The line is linear or more or less. It's unrelentingly negative. We are looking at a sterile population by 2040. Their industry will say, oh, it's real, we can see the data is very powerful, but it's not chemicals. That's rubbish, absolute rubbish. It is chemicals. We can take chemicals at the concentration that is in the urine of the people sitting in this room and produce these effects in rodents, in fish, amphibians, and other creatures. So we have to get really, really serious about this. Fortunately, I will now focus on this second problem. Fortunately, not every chemical is an endocrine disruptor. 10 years ago, we didn't know how to measure what how to decide whether a compound was an endocrine disruptor or not. We now have developed all of the assaying or put together the logic of how you should do that. So we can avoid endocrine disruptors, avoid chemicals that produce these low-dose effects. So clearly, if you're going ahead into a circular economy and you're taking matter and bringing it back into the economy, better not have these effects. It's got it going out, let me tell you. We better make sure that we don't keep bringing it back and recycling it, particularly with the impact it's having on our species and everything else. So then the question comes down to this building of a competence that we do not have. And you ask yourself, are there simple rules? What could we possibly do to acquire this competence? There are actually, I believe, some simple rules. So first of all, if you're practicing chemistry for sustainability, number one thing is about the protection of life. Now, when you say something like that, that means that you have to know a lot, because no chemist can typically say, well, I'm going to go out and protect life, without becoming very multidisciplinary with a whole lot of other disciplines that know how to protect life. So any form of circular economy will engage a massive interdisciplinarianism that brings together the appropriate fields to protect life. This is a very difficult field to fund because it takes a long time to do things properly. Our agencies funding agencies aren't set up that way. They like bang, 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 papers, papers, papers. They like to see action. But if the action's in the wrong direction, you clearly have a problem. So really, when I teach students about the pursuit of sustainability, I tell them, look, this is more a vocation than it is a career. You are going to have to learn a whole lot of things beyond just being a chemist if you're going to be successful. You are going to be not so much worried, at least intellectually, about you and your family in the near term. You're going to be worried about the long term. Your focus is going to be on how we do what we do today is not going to harm our species and other creatures in the future. None of us really knows what sustainability is going to look like when we get there, but we sure as heck know what it doesn't look like now. So I see that sustainability and the building of a circular economy around it is a direction and not an endpoint. You head away from things that are not going to work, like carbon, energy, towards solar energy that has every promise of working, etc. It's a directional thing in the moment, and you keep making course corrections when you run into problems, and if we're lucky, we'll get there. Championing biodiversity is absolutely critical. It's about the love of life. If you do not love the other creatures, and if you say it's all about humans only, I think we've had it. I think as a species, we don't really belong in charge of life if we aren't prepared to really invest intellectually with our full humanity in protecting life. Well, I could go on and on. I think about this all the time. I have for decades, but I'm going to pass it on, and I'm really grateful to be here with these wonderful people at this conference. It's been really quite inspiring.
Thank you, Terry. Rajendra?
So, circular economy is a noble goal. It's a lofty goal, and it's out there. The reason I say that, it was mentioned that, we have to apply the concept of circular economy material-wise or product-wise, and we can't be looking at it in totality and try to go slow. Pick a particular system and try to apply circular economy to that. Now, if you think of any material system or anything that we use, be it energy, be it water, be it food, be it steel, be it aluminum, the moment you get away from reuse, refurbish, and repair, the concept of repair has practically gone out of our lives. There was a time when things could be repaired and could be reused. We don't do that anymore. So the moment you get away from these three, and you are now getting into remanufacture or recycle or, kind of restarting the whole system or remake, basically, that circle is never going to be a circle. So let's look at aluminum. It is very clearly understood that if you recycle aluminum, you are going to need 95% less energy than producing the same amount of aluminum from primary resource. You are going to generate 75% less greenhouse gases than what you would do if you were to produce it from the primary resource or from the ore. But what that means is that you are still going to need 5% of the energy, and you are still going to generate 25% of greenhouse gases. So that is not ever going to let you complete the circle. It will never be a circle. The idea is to get to that circle as close as we can, depending on what product we talk about. Some will be more circular than the others, but the moment we get away from repair and reuse, we are going to lose that circularity, and we have to understand that and try to get to that goal as much as possible or as close to it as possible. Sustainability, there are lots of definitions of that, and we have heard not just in the last 2 days, but everyone all of us who are working in that field have seen many of these definitions, that we should not be borrowing it from the next generation. Basically, that's what is being said in all these definitions. But we don't know what the next generation needs. We've already seen that, things are changing. We have no idea what the next generation would need and what the generation after that is going to need. So how do we know that we are borrowing from them or not borrowing from them? So if you really want to look at sustainability, it's basically being prosperous. All of us want to be prosperous in our generation, in the next generation, and the generations to follow. Everyone would want to be prosperous. So whatever is needed to be prosperous at a given time, and to be able to have that, is basically what sustainability is. So it's more of a philosophical thing than something tangible, but that's how I see the concept of sustainability as it applies to the society. Product-wise or sector-wise, it was mentioned the rare earth metals or the windmills, the energy sector. it was said, energy sector had a goal of 2020, meaning that 20% of the energy in the United States would come from the renewable sources, solar and wind and hydrothermal and whatnot. We are nowhere near that. We are less than 2% when it comes to renewable energy. So what's happening? And that's where the interdependency of things start playing. So windmill, yes, we can have wind energy, but if you look at it, when you fly over whichever city you want to talk about today, you see many of these windmills churning, and you suddenly see that two of them are not working. So there are a whole bunch of them which are turning, but the two are not. So what's going on there? It's not that they're getting a different kind of wind there. What is happening is that the windmills that we have today are gear-driven. And there is serious problems. There are problems when it is gear-driven, that these don't work very well, and they stop. So what do we have to do? We need to switch to direct-driven motors for these windmills. What does that mean now for having direct-driven motors? What that means is, for each megawatt of windmill energy that we produce, we are going to need 500 kilograms of neodymium metal. Okay, each megawatt is going to need 500 kilograms of neodymium metal. Where is that? So Molycorp is the only company that has any rare earth resource in the United States, in Mountain Pass. And if they were to operate at 100% installed capacity, today they are operating at 11-12%. If they were to operate at 100% installed capacity, they will produce 2,800 tons of neodymium, and that is it. That is just good enough to take care of all the hard drives that we use. So look at the interdependency of one area on the other. Here it is, the wind energy depending entirely on rare earth metal resources. So we can talk about it. It applies to auto industry so much, to the electronic industry so much, on how sustainability or the circular economy concepts can be brought in to as much of an extent as possible. I mentioned about corrosion and said that I'll try to link it to how it relates to sustainability. One of the terms you must have heard about is called resource productivity. Excuse me. So that is a little different from what resource intensity is. Resource intensity is what you get by the investment of a certain amount of resource. So in the agricultural field or in the food industry, it's called crop per drop. So similarly, for different areas that would have different definition, but resource productivities, and there was some very nice data that was presented yesterday as to how much of a material needs to do more to be sustainable. So resource productivity means that if a certain mass, let us say a pound of steel, what it is doing today needs to do 10 times, 100 times more going forward. So that is resource productivity. How does that relate to corrosion or corrosion education, or why should a sustainability engineer need to understand that? United States loss of corrosion is $1.7 trillion, 6%. Direct loss of corrosion is $1.7 trillion. If you add the indirect cost of corrosion, it doubles up to 12% of the GDP. $3.5 trillion US dollars is going waste through corrosion. If we can improve the resource productivity, meaning that we do things that does not degrade the material, that does not allow the material go to landfill as a rusted steel, imagine the impact we have on the sustainability and how we can make this thing circular. So no matter what material system, product system we are talking about, the concept applies very much, but we have to understand that government needs to come and play its role. Society needs to come in and play its role. There are taxation issues. There are tariff issues. We hear that these days, a whole lot about it. So all these issues, which is under the government's control, they have to work on it and they have to support this concept. Otherwise, this is going to remain a lofty goal, as I mentioned in the beginning.
Thank you, Rajendra. Now, Ashley.
So fundamentally, I see the circular economy as a framework towards helping achieve sustainability. It's a framework that requires that technical drivers, policy drivers, and economic drivers all be aligned. And if I understood the perspective of our first panelist correctly, he was a little more optimistic than I am about the chances that this will kind of naturally all fall into place. I think that with the amount of time it would take for all of those drivers to become aligned and for the circular economy to become achievable across lots of product sectors in a time frame that will actually matter before we're maybe past a point of no return is very unlikely. So I think that we do need to be much more active in trying to incentivize the circular economy. Unlike our second panelist, I'm a little more optimistic about our ability to change people's minds and to form them later on than when they're very, very young. I think I have to feel that way, or otherwise we kind of have to write off currently everyone except the youngsters. I think for many of us up here on the stage who are at this conference, sustainability is not something that we learned a lot about when we were younger. We did have to come to it later on in our careers. As I was talking about in my talk earlier, and as others have noted, sustainability concepts are not something that are really integrated into material science or other science and engineering curricula at the moment. So we were all successful in changing our minds and becoming very passionate about this later in our careers. So I have to believe that others can be too. As a science communicator, I am passionate about how we communicate. And I think that that comes into play both in how we look at education and then how we look at our responsibility as scientists. So from an education framework, fundamentally, we do need to start integrating the technical knowledge around sustainability into curricula like material science and engineering. But actually, equally important is to do a better job of educating people about soft skills. And so a few of those that come to mind are systems thinking, analytical thinking, the framework to tackle very challenging, complex problems that are inherent when you look at sustainability. I think too often when you look at college courses today that have, say, hundreds of students of them, even tens of students, and we give people, at least in the US very popularly, exams that have bubble sheets on them, it's multiple choice, or there is one right answer that you can easily grade. We don't often teach people how to approach a problem, because the answer, as we've been talking about in sustainability, is all too often it depends. It depends on the energy source of the locality. It depends on whether or not we are near an ocean or if we're further inland. So many things depend. So how can we teach people to approach these problems, not get scared of them, but kind of have a framework to look at all of the details, put them together, and not need to come to a one right answer. Secondly, I think it's really important that we teach collaboration skills. So even though we should be teaching more technical details about sustainability in our curricula, it's never going to be feasible for, say, a material scientist to know everything about every discipline. We have to understand enough about the other disciplines to know which ones are relevant to the problems we're trying to solve, but we really need to teach people how to reach out and start collaborations more. And then lastly, I think we need to teach leadership skills. So many things about sustainability are an adaptive challenge. There's something that require change management of people. And that's not something that scientists are often taught about, how to be good managers. If you think about change management, one analogy I think about, if those of you in the audience, anyone have seen Game of Thrones, this is like the ultimate adaptive challenge, change management issue where you've got these white walkers, these scary creatures that are going to come and kill all of humanity. And you have Jon Snow, the protagonist, who has seen the White Walkers. He is the expert on White Walkers. He has seen them in person, and he comes and he tries to tell everyone, the White Walkers are coming. They're coming for us. They're going to kill us. They are the existential threat. And of course, climate change, in this case, is very similar. Now, we, the scientists, are the experts. We've seen the data, and we need to tell everyone else in a way that is believable. We need to not only tell them in lay terms, but think about the people part of this challenge and take that responsibility for developing those skills and making a message that people understand and believe and feel like they can do something about.
Thank you, Ashley. I pass on to Martin.
Thank you. Well, a lot of smart things have been said, and I think I can actually beautifully continue from what you have been talking about. Maybe I can just add 3 brief points. About people, about cities, and about policies. So people and mindsets are things that would have to change to approach problems in a new way, right? We just basically just got a little introduction into what I learned during my own Master of Public Policy. People learn through stories. You have to have a compelling story for people to listen, actually pay attention, and understand on a deeper level what the issue is about. So one of the definitions that I heard about the circular economy is waste equals food. Basically, if you think of a tree in an ecosystem like a forest, none of the byproducts, you can't even call it waste, none of the things that the tree produces, no matter if it's oxygen or water sequestration or dead leaves, or even when it dies, the materials become food again. So there's literally no waste. And I think the circular economy in its ideal form is not about reducing waste, but eliminating waste by design. And you would have to have a compelling story to tell for people to understand. Nature-based solutions can be quite effective because of that. If you think of cities, second point, as ecosystems, then you also see that lots of resources can be shared for mutual benefit. And you can eradicate waste in many ways, or at least fundamentally reduce it. Some examples would be closing the water loop here in Singapore, which is a huge success story about reusing, recycling, I can't say remanufacturing, but you could almost say that as well, water. Beautiful example. In the Netherlands, they took food waste, food that could not safely be sold at supermarkets anymore, and actually made soup out of it, which was totally healthy and a benefit from something like a new valuable product that had not only financial or ecological value, but also social value because of a nourishing soup that is provided by something that was considered waste before. It's literally waste into food. And yeah, of course, you can also talk about zero energy buildings. I did a workshop here in Singapore on a visioning exercise on sustainable cities, on circular cities, how Singapore could be more circular. And one of the participants came up to me later and said, oh, you know what? Before in circular economy, I always thought about more efficient buildings, but I kind of forgot about the people inside and what their jobs would be and how they would live together. So I thought that was a very interesting insight that circular economy is not primarily about technological solutions, but about how people want to live better together and maybe possibly also in harmony with nature. And maybe my last point could be about policies and measurements connected to that. So I do think that green procurement is a big part of the solution, which would also be driven, for example, by cities. Cities are also a very overseeable unit of change for climate change, as you can see in the discussion. It's not too small, but also not too big to feel a certain kind of connection of community to actually get action started. There is some circular economy legislation, the circular economy package by the European Union, I think came out last year or was maybe updated earlier this year, which is an interesting example. I think it focuses a lot on recycling, but it's definitely a very good start to get somewhere and also to get the conversation started. And to be honest, industry says maybe you could be a bit more ambitious with that. And finally, about the measurement of circular economy, which is a very important thing that we touched upon as well. It is difficult to find a good measurement. I think Circular Economy, the Dutch company, suggested the Circularity Index at the World Economic Forum last year, if I'm not mistaken. They said, I mean, you could definitely argue that's a pretty rough measurement, but they said about 9% of the world is circular right now. Why? Because 9% of the resources go back into the resource stream, and they definitely exclude thermal recycling or burning. So 9% of the resources go back, and that's an interesting start to see how something like this could be measured. I think more work has to be done there. Another innovative idea could imagine would be, since what gets measured matters in the end, maybe newspapers could start to publish on a daily basis, together with the weather or stock horses, something like the carbon parts per million equivalent, and then see how it's going, just to bring more awareness to these issues, because how many people talk about that. So I think there are ways to change mindsets and create new sustainable ways, but also create new ways of thinking. And a lot of it will have to do with how to measure and what kind of ideas we transport to people through better stories, that explain why the circular economy is relevant to how we want to live together in the future.
Thank you, Martin. We have 8 panel members engaged us 5 minutes each about their experiences, their perceptions about circular economy. It's very hard not to resonate with what they said, and it's clearly they made their points very elegantly. I like to kind of summarize them so that we can form that as a basis for the future forthcoming half an hour discussion. It's clear, they all said, human species only exist on the planet Earth. And the whole cosmos and the universe is vast, but human beings, human species, seems to exist on the planet Earth. So what we have is planet Earth and the human beings, and sustainability of planet Earth as well as human beings is extremely important. And circular economy is presented as a solution, the solution, part solution. Some said it is a product. It is actually not necessarily a process. So if we have to understand this, and in a way, a larger audience who are not familiar with circular economy would like to capture it, we would need to see and accept the fact that it has been suggested by the panel members. For a long time, the human beings, more or less, living on this planet, the numbers are somewhere 3.4 million years to 500,000 years. It depends on what number you like to choose. Let's say 500,000 years to now. If you look at that span, for a large part of that span, they were living sustainably, much more circular, whereas the last 100 or 150 years, it has gotten to be more and more linear. So the message that comes out is, we gotten used to the linear economy, which means unsustainable progress on the planet Earth. That means it is not sustainable for human beings as well as the planet Earth. They also stretch to the point, if we continue to pursue a linear economy, we would become a sterile population. So here, the panel members are allowed to stretch their foresight, insight. So they do project it as a way, very urgent, very important. They associated this with the climate change and other major things that are happening in the society that involves extreme weather conditions. That includes Singapore, just now been announced, the raising sea levels would actually mean Singapore has to spend more than $100 billion over the next 100 years to be much more sustainable and a livable place. So this is applicable to many other cities, many other communities around the world. So for the benefit of our discussion, also to relate to this conference, which is about materials, nano and micro materials, supported by NSF USA, I like to ask the panel member to comment on either one of these three based on their own personal interests. The way I would organize this into three themes. First one is to change the behavior of the people and the businesses. It is done through the value system, or at a much more narrower level would be standards and regulations. So let's say, what kind of standards and regulations, what kind of opportunities are there, what are the gaps here, what need to be done in terms of developing or improving the standards and regulations. So with the goal of changing the behavior of the businesses who are basically pursuing the linear economy model, and then of course change the behavior of the people. Second one, it is about education. While somehow certain elements of sustainability is picked up in the early years of our children, but it appears we are not getting enough grounding in the university education. The question is, in the university education, what kind of things that we need to do so that we could see a much better understanding as well as embracement and following on circular economy. And the third aspect I like to say is for everything behind all this is materials-based products and services. So, and this is a conference about materials as well, and we have at least 50% of the panel members as their day job pursue the materials research. So my question to them is, what kind of materials, chemistry-based innovation they like to see that human beings should go about or go after, so that we would have the circularity, circular economy, sustainability would be much more enshrined, much more happening thing rather than just a vision. So I repeat, I invite the panel members to comment on either one of them or all three of them. It's up to them. After that, I open this for the floor so that you can ask the questions which are really on top of your head. So I repeat, the first one is about standards and regulations, what kind of gaps or opportunities that need to be done. Second one is what we need to do or how we need to pursue so that we have a stronger educational practices in promoting circular economy at the universities. And the third one is about really the material breakthroughs and innovations, what kind of things we should pursue and how we should go about. With this kind of boxing, so that we have, everybody has a chance to use your background and your own passion to comment on them. So we could go any particular sequence. There is no specific sequence, so anybody can go first. Yes. Carol, please.
So I'm going to comment on the first one. So this is, how do you change people's behavior? You were talking about legislation. I think the issue is we're just too comfortable. It doesn't matter to us. And I think that, you know, there's a great deal of hubris here in this room. I mean, I have it as well, that we are not acting as if any of this mattered. And I go back to Elinor Ostrom. She won the 2009 Nobel Prize in economics. She did game theory work on sustainability, and she did game after game trying to see what made people care. And it's actually, if people are too comfortable, they just won't go to the optimum. They will not. So it's the people that actually have fewer resources that we should be looking to for education and guidance and leadership, because for them it really matters and they care. So we look to India, we look to South America, it was talked about earlier today, to Colombia. The people in Colombia desperately care about making a difference. And if you want to see circular economies, people repair things. We just don't. They get the most out of everything. So I think that by taking this, it's not Western, it's a Western, it's a view from people who have much, that is not where we're going to learn how to do what needs to be done. So, and I think we have much to learn.
Thank you, Carol. Adrian?
Yes, continuing from what Carol says, people care, but people care about different things. Yep. So in the circular economy research that we do, we want to understand what do consumers care about, when they buy a remanufactured good. And one good example of a company that has been doing remanufacturing very successfully in a very responsible manner is the Apple. Yep. Apple take back the products and remanufacture them, and they sell them as a remanufactured good. They honestly sell them as a remanufactured product. Whereas there's a lot of other brands that allows the product to rerun through the production line 10 times and sell them as a new product, a good product. But those people who are in manufacturing, they would know that, because of the yield issues, many electronic goods have to go through the production line at least twice. So what do consumers care about? Different people are motivated by different things. Some are more status conscious, some are more cost conscious, and some are more environmentally conscious. So there are differing levels of consciousness towards things. And we found that, Europeans versus Asians have different levels of values. So they all have the same values, but differing levels of those values. Now, Europeans we found, are very good in environmental conscious. So they will buy into a green product. They will buy into a remanufactured product simply because they are more passionate about environmental issues. So if we're to market the product as being a remanufactured product, and that consumers know that remanufactured products actually takes lower energy, it's as good as a new product, and the process is established, they will buy into these remanufactured goods. Asians, on the other hand, are very different. Whilst they claim, they have this claim that they care about the environment, they trust in brands. So when they buy expensive brands like a Gucci or a Chanel, and these brands gives them the idea that they are environmentally good and caring, they trust the brand. They don't care what goes on behind the scene. So they are more status conscious. And some parts of Asia are also very cost conscious. Not because of low cost, but they care about cost versus quality, right? So they want to get the best value for money. The price may not be the most important thing, but the quality cost ratio has to be good. Yeah. So in Asia, if you were to market your remanufactured product as, oh, this is good for the environment, it takes less energy, it doesn't sell. You have to market it in a different way. That this product, for example, it's of higher quality, equal quality, and lower cost. Yeah, the remanufactured Apple that you have is of equal quality but lower cost. So, a lot has to be done from the management perspective, the marketeer's perspective, to market the product to the right segment, in the right message.
Thank you, Adrian. David wants to.
Thank you. I really want to reemphasize a little bit what Carol was talking about. Me and my wife talk about this a lot, that there's disproportionate populations that are affected by climate change. And we've seen this happen now. Out of the Middle East, there's been a huge migration out of there, out of Africa, heading into Europe. Some of this, the vast majority of this, is geopolitical, but some of this also has to do with fighting for resources, because these resources are no longer available because of climate change. In the United States, we see a very similar thing. We have geopolitical migration coming from the south, but some of that is also driven by climate change because people are fighting for resources. Now, how do we fix this whole climate change and so on? And I hate to say the word, talking about putting policies in place, but I think back in the 50s and 60s and 70s, where the tobacco industry hired some very powerful legal and marketing people and really push back to make sure that no one knew the real dangers behind tobacco and the acetone and upping the nicotine in the tobacco to try to make it even more addictive. In the 70s and 80s, when the government started implementing policies to make sure that the industry had to share this information and pay to share this information, then we saw a decrease in the amount of people that smoked in the United States. And so maybe policy is part of the driving force that can help us fix that, and I hate to admit that may be part of it. Back to the educational part. You're talking about materials. I was at the grocery store the other day, and I saw a package of applesauce. It was sitting on a shelf at room temperature. And I looked at this thing, and there had to be as much plastic by weight as there was actual applesauce in this thing. So I'm thinking of a parent that puts that into their child's lunchbox, and this child takes this to school, and they eat it, and this thing's just going to get thrown away. If it's at room temperature, I can guarantee you that not only is there as much plastic as applesauce, but this thing is a multi-layer plastic, which makes it almost impossible to recycle. And so this speaks volumes to that child as to just throw it away. Just get rid of it. It'll be fine. Don't worry about it. Now, we could go back and talk a little bit about what we mentioned yesterday about, well, maybe we should burn this, and that may be a viable option as we may be talking about this. But these examples speak volumes to what our values are. This morning, when someone asked about, do you own a car? Do you drive? And I kind of rose my hand because I kind of drive. I have a 2000 car, and I just broke 50,000 miles. So compared to the average American, I don't drive. But yeah, I do, but not to the extent that most people do. And it's very easy. I just make sure wherever I live close to work, because that's your biggest impact is driving to work. I know people drive an hour and a half every day to work. And I did that when I lived just outside New York City, because you can't afford to live in New York City, so you got to drive. But that speaks volumes as an example. So setting examples of trying to reduce our environmental impact and closing this loop so that we're reusing and not using these food containers that are multi-layer. I get this, that it's for safety, right? We need to, plastics is great. This food packaging allows us to store these products on the shelf for nearly ever, and they never go bad. Whether it's the package around a Twinkie or whatever it is, I get that there's a lot to do with food safety, but there's also some long-term adverse effects that we're going to be paying for a long, long time.
Wow, David, you convinced me that how to be much more frugal with driving. I have a car too, and I've been driving, say, I just checked it, 60,000 kilometers in the last 10 years. He just now said, I think 20 years, right? Yeah. 20 years and 50,000, so yeah, miles. So, which is more or less very similar. That's very good. So I think it's a very good point about how we actually lead our lives, and there was also some mention about flying all the way. It does contribute, but some things are very essential. People have to do that, and let's hear from other speakers. Yeah.
So, of course, we're all down here in Singapore, coming from the United States, and we have very big carbon footprints from these plane flights. No matter, I'm very impressed. No comment. That's wonderful that you are living close to work. I think is a very good thing. I'd like to address CRM's three questions sequentially. If you look at the university and you ask yourself, Noel, when it comes to sustainability, it's pretty clear that we're going to have a common way of thinking, that we ought to be able to talk across disciplines about sustainability so that everybody understands when you say something exactly what you're saying. And so the question is, what are the core ideas that can be accepted in the Department of Classic Languages, the Department of Chemistry, the business school, really hard nut to break, frankly, and other places vis-a-vis sustainability. And there's a really fantastic thinker about this. He was decades, if not a century, ahead of his time. Name is Hans Jonas. He died I think around the early 90s. And he wrote this remarkable book, The Imperative of Responsibility in Search of an Ethics for the Technological Age. And in essence, what he says there is that through all of our societies, the big ones and the powerful ones anyway, there are some distinctive societies that we've heard discussion of where people are actually much more in touch with the environment and work much in a cyclic way with it. But what he says is that all of our ethics up to the point of the Industrial Revolution worked fairly well because they did not need to cover the powers that we now have through science and technology, particularly chemistry. In other words, we really did not have the power to mess the environment up. The environment was kind of a dangerous place if you're, say, living in Europe and the forests in 1500, and you did not go very far away from home, or you might not have come back. We've now really turned the tables because of the power over the environment that we have acquired through science and technology. And we are not yet ethically mature enough to handle this power. So, for example, you can think about it from that the ethics typically come out of the great religions, and you can think about it from the point of view of Christianity, and we have 10 commandments. Now, if you look at that, depends on what branch of Christianity you're from, but 3 or 4 of them have to do with your relationship with God, and the rest have to do with your relationship with other people that you meet. You have to meet the people to turn on the commandment. And so what happens when you're not going to meet the people? What happens when they're going to be 3-year-olds in 2500 that you're doing things today that are really messing it up for them? And so, in fact, there will be totally different. I'm absolutely convinced. If there were 12 commandments, one being be kind to other creatures, and number 12 being look after the environment. Because you can get through life thinking, I'm a good person, I'm doing all the right things, but actually you're blind to the things that these other powers are bringing you, and as a consequence, you're doing a lot of damage without even knowing that actually that's a bad thing to do. And I think we're all trapped in this, frankly. It's very, very hard to deal with. Now, the second thing is, from a policy point of view, what do we have to do to start dealing with these big existential threats? Now, you can begin and you can say, right now, our leadership hasn't quite got it, at least in the United States, right? And goodness alone knows what we're going to do about that. And this brings you back to the point of investment in politics. Should politicians be able to receive very large amounts of money from vested interests? It's a really tough question. But when it comes to the other area, the area of low dose of adverse effects, where chemicals are impacting us all in ways they really weren't supposed to. I mean, a chemical, that we chemists made, for example, a drug. It was supposed to do its thing. It was supposed to fix a problem. That was it. Wasn't supposed to do anything else. That's not the way it works. The drugs are excreted. They go through the sewage treatment plants. They get into the rivers, and they really mess up aquatic life. Pesticides are doing the same thing. And unfortunately, a whole lot of chemicals that are in our houses and homes, for example, flame retardants of various kinds, are doing causing exactly these problems to us while we're in the home, and we're hardly aware of it. And so there is a problem, and the problem is how the regulatory agencies decide on what is an acceptable chemical to put out there. And it has to do with really a 400-old-year idea by a guy whose name is a very big name, condensed to Paracelsus. And that is the dose makes the poison. And so everything's poisonous if you have too much. Nothing's poisonous if you have too little. Unfortunately, what's missed there is the way scientifically or chemically the endocrine hormone system works, and this system is absolutely overpowering in controlling how life develops. So when you're a baby in utero and you're thinking about what happens to you, your spine is being made because of hormonal signals coming in, where the hormone concentrations are supposed to be coming at the right time, at the right concentration. Reproductive parts of your body are being built at other times. And if you mess with the concentrations and the timing of the income of the hormones, from the mother's glands and the baby's forming glands by having chemicals that are surrogates of the hormones. Either they do what the hormone does or they block what the hormone's supposed to do, you're in trouble. And we have tens of thousands of papers with animal and related studies saying that occurs. So actually, what regulatory agencies do is they start at a higher dose and they come down to a lower dose, and eventually they get to a point where they think there's no effect, and they say, then they say, okay, well, we'll have a reference dose, the amount you can be exposed to, a couple of orders of magnitude below that, and then it's all over. Unfortunately, they don't go down to the low doses where the hormone systems really have their impact. We need to turn around. Our regulatory agencies should start at a low dose, and they should build up. And then the final point was, the last point was, oh yeah, materials innovation. So first of all, number one thing, if you want to produce sustainable chemicals, is you make them out of the same elements that life is made out of. If you're going to put chemicals out there and they're going to be wandering around willy-nilly in the environment, and they use elements that are typically bound up in rocks and are not moving around, life has not had to develop with those exposures to those elements. So when we mine them, refine them, and we put them in our technologies, lead's a classic example. We've been poisoning ourselves with lead for millennia. These elements encounter us, and they have unfavorable chemistry for life, and you end up getting sick. So sometimes we need to use the elements. We need to be very careful when we do, and we need to recycle them, not throw them away and put them into environment. That's very big. The second thing is we have to test. We have to be much more competent in testing in the way that I spoke. You make a new chemical, don't put it out there and wait for 20 years to figure out if it's an endocrine disruptor. You should know, before you put it out there, that to the highest standards of contemporary science, it's not an endocrine disruptor. We didn't know how to do that a decade ago, but we do today at a very high level know how to do that. Governments did not produce these assays. They wouldn't have been allowed to. The stakes for the economy of dealing, the chemical economy of dealing with endocrine disruption are enormous. Now, when you're looking at what's happening, you have no choice. You cannot ignore this despite the fact that it's going to mess up a whole lot of company products, because it really is. You just simply have to deal with it.
Thank you, Terry. On this note, I think we are left with another 30 minutes. It's an opportunity for asking questions from the audience. Could I ask you to ask questions to any panel members? And in case you want to make up your mind, actually we worked out something like 30 questions are already there. You don't have to exactly repeat them. In case you need the key words, you can take from there and then rephrase them, combine them. You can ask the question the way you like. So I'm not leaking the examination questions, right? That's just a way to get the conversation. And actually, before we were thinking about myself and Sudipta, how to manage this panel session, we said, let's come up with a composite list of questions. So we together came with this long list. So feel free. It doesn't have to be part of that, or you could combine them in a magic way. But ask the sharp, interesting questions so that we can tap their insight and experiences. And we send the mic around. Please ask the questions.
Yeah. Hello. My name is Abdul Matin. I am from Bangladesh University of Engineering Technology, Buet, Dhaka. So I am the associate professor over there, and I was performing or doing the departmental head. And actually from yesterday, my headship changed to another professor. It wears interval. So basically, how did I get interest on this circular economy conference? During my master's study in NUS, I took a course under Professor Sriram Ramakrishna, so I know him very well. So my direct question is, as I am in the engineering education, so how do we, because no doubt in it, circular economy is very, very important, and if I am children, I think that would be the best time to learn, but I'm learning circular economy in my professorship life. So then how we can incorporate this importance of circular economy in our engineering education? And also in my country perspective, I think we should start from the primary, secondary school to learn them, to teach them, to make them awareness about the importance of circular economy. So these two questions. One is like the basic education, how to incorporate the circular economy. And another is like our higher education, the university level. Thank you very much.
We put Ashley on the spot.
So I think the essence of your question was, how can we teach the circular economy in engineering curricula? And I think one really powerful way for doing this and emphasizing the critical systems thinking and analytical skills I spoke about earlier is to start with a problem, and maybe one that industry has, something that a student can see a tangible outcome of what they might be working on, and to frame a problem around what industry has, and to teach someone first the framework of the circular economy, how it works, and then say, how do you come up with a solution to this problem? I think a lot of times we can spend time in our courses teaching these fundamentals, teaching out of textbooks, but taking real life examples that people are facing today and put it to the test as a problem, I think can incentivize people to want to work on it because they can more quickly see a possible outcome of what they're working on. But then it's, to have a real world example instead of some theoretical thing that you're working on in a textbook, I think can also be really powerful.
I'd have to agree with Ashley exactly. And being in an engineering college, we're ABET accredited. And so anybody who's going through that process know there used to be A through K, now there's 1 through 7, but one of the outcomes that we need to address in higher education is social impacts. And so every class we have that has a component of that, this is a perfect example of where we can bring that in. What is the social impact that the students are learning? And the culmination of this, where we really pile this on, is in the senior capstone design projects. So this is where these undergraduates are getting ready to graduate. They're doing this their last 1 or 2 semesters, and they're working with industries to solve a real problem, and having that incorporated in that curriculum. I'd like to say that all of our students get that. That's not necessarily true. I'd like to see 100% hit that we do have a sustainability component to the senior capstone design project, but it's not always the way it works out. So I think that is a good way to bring that in. But to your point, then asking the question about where do we bring it in earlier, that still comes back to just, I think, through examples and inspiring students and telling stories. I heard that earlier. And I got this many years ago. A gentleman by the name of Gene Tackley, friend of mine, he won the Nobel Prize with Al Gore. And if you Google Gene Tackley's name with Jon Stewart, he was on The Daily Show. It's a hilarious one. Gene Tackley had just published a paper talking about wind energy and trees and how we have to be smart where we put trees and wind turbine blades. And Jon Stewart put the spin on it. Well, wait a minute. Are you saying that wind turbine blades are being destroyed by trees. The trees are bad, so should we cut down trees? And he went on to say, well, what if we cut down the trees, burn the trees, capture this energy, make electricity, and have big fans blow the wind turbine blades? And Gene comes back and is just looking at him. Gene's kind of a dry individual. I'm not really following your logic. But giving examples and stories like that, Gene emphasized about telling stories. And it's easier to remember a story than it is some stupid equation. So.
So I think that what we're talking about is pretty darn conventional. You know, put it in our courses, do it in capstone, blah, 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 blah. If we're going to make a difference, we've got to train activists. They've got to be willing to act. That's what Greta Thunberg is doing. She's making people care. She's turning them into activists. If we don't do the same thing, then we are selling our students short, and we're certainly selling our planet out.
So myself Prabhu from ICR, Indian Council of Agriculture Research from India. Sir. Secondly, my question is, last 2 days we are discussing about so many circular economy adoption in different departments, for example, electronics, electrical. What about agriculture? Because Sir rightly pointed out crop per drop. That means agriculture is, because after 10 years this scenario may be changed. Suppose what we discussed today, that hard disk recycling, everything, it will change within 10 years. Maybe the mass may be reduced, some new technology may be introduced. So those things, the scenario may be changed. But food, we cannot change for food production, those things. For how to adapt for circular economy in agriculture aspects. Because I didn't find even a single paper last 2 days focus on agriculture. So how to work in future, especially for agriculture. Because what we discussed last 2 days, that maybe that scenario may be changed after 10 years or after 10 years. So those things we cannot predict. So how to address for especially agriculture sector?
You know, basically thinking from the top of my head over here, I mean, agriculture also, we have to treat it as an industry. Similar to, you mentioned electronics or, any other industry. So that industry, the agricultural industry, will also change. And when you say that it's going to remain the same, maybe, obviously when we say agriculture, we're talking about food. So yes, the nature of that will remain the same. But the concept of circular economy could be changing in that sense too. I mean, we're talking about here, the theme of this meeting is this nano and micro materials. How do we use them to make the process more and more circular or sustainable? So if you look at agriculture, there are so many products or byproducts of agriculture which we can take and convert them to a size or a scale where they have very unique properties. I mean, we know of rice husk being used as converted into carbon nanotubes. So we understand that materials develop very unique properties when they get to that length scale. So just as any other field, we have the opportunity even in the agricultural industry to apply the similar concepts that applies to other industry like the electronic industry. I was thinking when you asked the question earlier about the different type of materials and what we are discussing here as nano or micro, the industry generates a whole lot of waste. So to begin with, when you talk of circular economy, the idea is to cut down on the waste as much as possible. Significant part of the waste that the industry generates, and we are talking any industry you think of, be it metal, be it food, be it energy, 17 to 20% of the waste generated is in this fine micro nano form. Okay? In power generation, coal burning, there is bottom ash, there is dust, the flue dust. All these things are materials in that form. If you threw that to the landfill, if you send that to the landfill, the circular economy is shot. So to keep it within the circulation, and it applies to the food industry, agricultural industry as well. So if you want to keep it into circulation, we have to take this material, which is a fine material, talking in general length terms, a fine material, and convert them and bring them back into the economy so that it remains circular. So specifically, I'm not sure if I answered giving you right examples from the agricultural industry, what could be done, but agricultural industry in the same way generates a whole lot of waste material, which is in the size range that can be converted into something where it develops properties that are unique for that length. Yeah.
So I will give you one specific example. Why don't you come here so that you are captured in them? Take that way.
So I'm going to give you one specific example that Florida and California has citrus greening, and especially for Florida, it's a almost $8 to $9 billion industry. It has cut down to 4. So farmers are not working on that. So there's 2 centers funded by USDA, that's one of the federal organizations, happened to be at UCF, led by Professor Santra and his team. There are a couple of things they're developing to sustain it. May not be circular economy, but they are all connected. One of the things is how to really spray those antibiotics and other things, because Florida has a lot of rain. Another hurricane is going to hit. So they're developing nano-silica proprietary formulation that will release those antibiotics over time. So now the amount of antibiotics has cut down. Otherwise, what will happen is that now they were spraying it, so every other week they will spray it. So this was loaded with antibiotics. So that's one example of an engineered material for sustained release of these things, and this is now being tried or being in the field trial, that's what I know. The other aspect is making sensors. If you understand citrus greening and canker disease, that's why orange juice is going up. So they're trying to make sensors so that how do you detect those type of disease well ahead in exam. I'll give you a specific example. For sustainability, that's one of the aspects as well. So these are some of my few specific examples.
So I'm going to talk about bringing nano to micro and then to macro. Yeah, and a good example of agriculture is what is practiced by Danone. Yeah, Danone produce milk, produce a lot of agricultural product. And, animals are creatures that produces a lot of waste material, dungs and pee-pee, right? And what they do to this is that, instead of letting those waste materials lie around on the hillside, which can be quite damaging to the vegetation, they digest all this material, yeah, and recover energy from this material. So some of this good practice is that, leave the place where you found it, as you found it, rather than, because, by having more animals, farming, we are actually imbalancing the nature environment, yeah, because, cows, goats are creating an overpopulation on a natural hilltop that is not supposed to have 1,000 cows gazing there. So I think in a very responsible manner, we have to restore the place where we found it. Yeah, thanks.
Sure. Okay, I'll keep it brief. I think what helps is to have a systems perspective, right? So I'm not an agriculturalist, I'm not even a technologist, but I would say you can tend the agricultural ground in a way that captures much more carbon, like 3, 4, 5 times as much carbon as it does now, right? That would be extremely sustainable, and it goes back to more traditional techniques of doing it, right? But then also think further than that. Think of in Europe, for example, there's a lot of waste, a lot of lack of sustainability because of food waste after production. In India and some other countries, from what I learned from a professor who works on water, a lot of the waste actually happens from the field into the process. So 30 to 50% of food goes to waste. So that's literally like all the water, all the energy, all the fertilizer, everything that went into that food is wasted because you don't have a supply chain that brings it to the person, right? So that would be the second thing. And the third thing is, think about not only how well you grow something, but what you grow in the first place. Because if you find a very efficient way of growing soy for animal feed, but then lead into a lot of meat production, which is a much more energy intensive than plant-based in the first place, then that might not be that sustainable, although the production that you use is extremely sustainable. So I just suggest to have a systems perspective and look at what are the full-on consequences, not only the technological advancements in planting, for example, right? And that goes back to what we talked earlier in measurement. If you have a better full-on eco-footprint, a better circular measurement, a better carbon footprint, start with the carbon footprint, but go into a full-on life cycle assessment, then you can see, then you can compare much wider than just certain kind of technology in agriculture things, but you can look at, are there better ways of doing their product? Are there better products that it could use? Are there supply chain problems, right? So I just encourage to maybe have a larger viewpoint on the issue than only looking at one part of the production process. And if you have a great story, if you find out something great, then write about it and tell a compelling story and, you know, help others to understand what you learned as well.
Yes, I have a comment and then a question. Going back to his original question is how do we educate, and also actually thank you for bringing out the essence of it's about telling the story. It's not about education, not about the equations, I say. So it's how you tell the story and developing those skills to tell the story. Touching agriculture, the Amazon was circular. We just made it linear, big time, thanks to agriculture, because somebody was thinking linear. So how would you use this simple story to educate not only young generation, bring it into the classroom, but most importantly, world leaders that resist climate change? Should this be education at the local? Should it be regional? Should this be a global discussion independent of national anthems and flags? That is my question.
Can we have your question? Sure. Also, if I can add to that one. Yeah, we'll have a few questions together.
Mine is on the topic of education as well, which is probably the most important objective to educate the future generation. And I think we have to admit that as academics, we have done a poor job of this collectively, because otherwise we would not be in this situation. So I'm really glad to hear this discussion. I agree we have to be wary of just continuing as we have been, because it isn't working. And an example of this, though I don't think it is intentional, is numerous times at this workshop, I've only heard discussions regarding the engineering discipline as the solution or the driver of sustainability. And I hope you've been convinced by listening to what Terry and others have said at this workshop that a lot of the sustainability challenges come from chemistry and from chemicals. And guess what? We do not teach chemists anything about chemical toxicity. We don't teach engineers anything about chemical toxicity, which means the people that are trying to solve the problem lack the required knowledge and education. So I think we have to educate in sustainability way beyond engineering throughout STEM. We also have to consider that so much of sustainability is driven by economics, so we have to be educating business majors, social decision sciences, public policy and management. It really has to be holistic. It's interesting, I've been studying environmental science for more than 20 years now, and watching the rise of the focus of sustainability and the importance of addressing that, but I'm concerned that environmental science has sort of been left out of the sustainability thrust, and I would put to you that you cannot truly do sustainability and evaluate if your process is truly sustainable if you do not have a strong environmental science component? Maybe that's something you could discuss.
If I can add to what Carol said, I think you brought up a very nice perspective of looking east. I think that's a very perspective, but if you look at east, how the whole tradition came into practice of circular economy, which existed long time back before we start thinking about it. I think it comes from the fact that in the Eastern world, people put life into everything. An inert material got a life, and that inert material is expected. So it's a long way to go for the Western world into that one. But my perspective, what Ramiro said, that how do you educate the world leader? We are going into an isolationist world more and more. We are getting into that theme right now. Every country going into isolationist mode. So how do you really educate? How do you penetrate that system? I think that's my question.
In trying to answer collectively the three questions, you know, we really need a break. We really, at this stage in our history, need something good to happen that even Donald Trump can take pride in. That Donald Trump, I shouldn't say even, that Donald Trump could take pride in. And actually, it is about the circular economy. And we have the ability to pull a lot of the CO2 out of the atmosphere that we put there fairly quickly. And if we were to actually embrace this, and it's really not that expensive, if we were to embrace it, what that would do for the confidence of humanity and its ability to live on the planet in a sustainable way would be enormous. And what I'm thinking of is trees. So China is, largely because Beijing is totally smitten with dust from the Gobi Desert, China is on a program to turn the Gobi Desert into a forest. There's about 4 or 5 plants, tree plants, that you can plant, and they're going to go find water no matter what. They may put their roots down 100, 200 feet, they will find water. And so this is also happening with the Green Wall across Africa. This is a 10-kilometer wall where they're putting in acacia trees mostly, and it's incredible what's happening. They're holding the Sahara back, and they're actually reclaiming land. You put these in, within 5 years, where you had parched land, you start getting water, you start getting birds, you start getting small animals, you start getting big animals. And Senegal, I believe, sort of got into it. I mean, this very poor country got into it. And they've completed their part of the wall. And at least if the things that you see on the internet are correct, the films, it's stunning. So what would it take for the wealthy countries to invest in the poor countries with green walls? What that does, of course, is it's pulling CO2 out of the atmosphere. I have a good friend who is an expert in biodiversity and what you can and can't do. Restoration of wetlands, this is what he told me, restoration of wetlands and planting of forests at the appropriate places can pull about 2/3 of what we put up back. That I think would be a very inspiring thing. This is something where Donald Trump and Vladimir Putin could get together in a really beautiful way, because Russia has large parts of territory that are suitable for this sort of stuff. So I think in terms of right now, we really need a break. And I think that children in schools all around the world, if this is taught to them, even if they were to see now what is being done in the small level that's being done, would be inspired.
Could I make a comment on that? What the questions were asked, because most of the questions have been related to education. There is common sense, and then there are things that need deeper understanding. So when you asked what you should be teaching at the level of high school and others, that's the common sense part, which you can tell them in a nice storytelling manner, which will hit home. When you talk of colleges and universities, that's where the rubber meets the road, and you need to teach them the specifics. Businesses, economics, understanding of that, the need of resources, all the collection systems, the sorting systems, everything that they have to understand to see the different pieces that go within the circular economy. That's what has to be taught at the university level. Coming to Trump or Putin or all these, I don't think that they don't understand. We know that they understand. So the politics and this fake news thing that has to be taken out of this, and they all understand that there is a crisis, there is work to be done to move the society forward in a sustainable way. So what is happening over here, be it a developed country or a developing country, there are leaders all over the place, who act in a way that we don't agree with. But the problem there is not that they don't understand, but that is what is serving their needs at this point, and that needs to be corrected.
Hi, I would just like to, by the way, I'm Surojit Gupta from University of North Dakota. I would like to add to some of the questions we had. Personally, I think that we are, too late in terms of circular economy. We need to have more people involvement. For example, there was this 16-year-old, she did a journey across the Atlantic, and there was like very toxic comments against her over the internet as well. So my question is that how can we make it a mass movement so that we can, irrespective of Putin or Donald Trump, they are not going to live forever anyway. How can we make it a mass movement so that the mass can understand? Because one of the comment I heard was, I didn't know about that there is a prediction that by 2040 that the population can become sterile. These are like very important comments, and how we can make sure that the mass is involved in this entire discussion so that they can participate in it and they can understand the importance of it. So one of the point was teaching kindergarten or school children. We cannot wait 20, 30 years. We have to take the action now. How can we be more radical about it and get everyone involved? Because this is one earth, one humanity, and we have to preserve it.
Since we're running out of time, we take all the questions and then we'll come.
I have a quick question for each of you. What would it take for you personally to become involved? When Greta Thunberg talks about this, she says, our house is burning. This is a catastrophe. This is an emergency. Act like it. So I've been trying to think about what it would take for me to treat it not as business as usual. So I think all of us should think about that seriously, because that's when something will happen.
She says, I want you to panic.
I want you to panic.
That's what she said.
Yeah, absolutely.
Hello, I'm Maharshi De, and I'm a graduate student at University of North Dakota, working under Dr. Gupta. So my question is again related to a bit of education, because I think personally educating the mass would make everyone sensible about the sustainability part. But when someone presented the facts that it is true, and I also agree that college students get more we get more education about sustainability. I mean, the opposite, that we don't get much of that education, but when it comes to school students, most high school students, they know about sustainability. But then, mostly when we graduate from high school, according to my perspective, we learned a lot about that. But is it that that education is making us that sensible to use it again later on in our lives? Because I would consider myself lucky enough to work under Dr. Gupta, where we are working under sustainable methods and everything. But many others who are working with material science and other fields, are they thinking about sustainability that much, even though they have got the education all throughout their high school they graduated with that, though, but still, is that education enough, or we should we should do something else to make it get into their system completely?
Good afternoon. I am Dr. Baswaraj Manu from NITK Surathkal. In continuation with Professor Surajit, I see that some of the concepts of circular economy or the circular economy itself could be standardized. So not only that, both from the incentive side, all the stakeholders, probably the industries, the people could be incentivized, they could be given incentives in order to recycle, reuse, or whatever it is. Same time, people also should be there. And at the same time, if you are not able to do that, mostly in the Eastern world that we talk that, we need a stick, right? So penalization could also be done if you are not trying to follow that. At the same time, at the individual level, we need to act and we need to perform so that we achieve whatever the standards, recycle, reuse at the individual level. No government or no people would, though there would be laws, but at the individual level, we should try to see that we achieve the circular economy concept. Thank you.
Thank you. Yeah, I just have a question related to sustainability. Do we need to incorporate, okay, I'm sorry, my name is Rajiv Asthana, I'm from the University of Wisconsin, Stout. Is there any cultural component to sustainability practices? We talked about education and business and management and, impact of, sustainability or the relationship of sustainability with, education and business and management. I'm wondering about the cultural component. Should sustainable practices, should they be cognizant of, cultural factors? I don't have a better example than, something very macabre. Some cultures bury their dead. Some cultures cremate their dead, right? Now, one line of thinking for cremation is that human body is a container, mere container for the soul. And you don't send empty beer cans to landfill, you incinerate them in a lighter wind. So that's not a very appropriate example for this kind of a forum, but my point is there any cultural component that should be incorporated in sustainability education or practices? Because education is becoming a lot more homogeneous worldwide. Is there any possibility to be sensitive to cultural issues? It's kind of a very broad general question. So.
Reason is we are almost beyond our time maxed out according to the co-chair, and also some of you may have other plans. So I'd like to take this and request the panel members, each one of them, like the final comments if you like to say. You can answer the questions or you can actually express things you would want to say, but keep it brief so that everybody has a chance to say something.
Talking about the educational part, it's only a small fraction of people that go on to college in the United States. And in high schools, maybe the high school you went to did teach sustainability, but I don't think that's a common thing. I think in rural America, you don't hear much about that. And so we don't have the opportunity to have a lot of touch points on this topic. And where we do get this, I only believe in the statistics I make up myself, but I saw a statistic the other day that 80% of Americans get their news from Facebook. And that's just not going to be an effective way for us to get the message out that we need to get out. We need to be passionate about this and get the message out. But it's going to be an uphill battle, particularly when we're seeing rollbacks in policies. The current administration has rolled back so many policies right now on environment, whether that's even on lead, how much lead's allowed in the water. Where are we going with this? We think that lead's an acceptable material. So I think that is part of the problem is getting that message out. In terms of selling this stuff, We talked a little bit about this. These bioplastics have to be cheaper, more effective, cost effective. You know, the pots is a good example that we talked about yesterday. But this pot is multifunctional. It outperforms any petrochemical pot. And yet, you know, it's also cheaper. So I think that's the way we're going to drive this home, is trying to get the message out there. And we just have to be the 3 Ps, you know, present, passionate, and just being, you know, truthful about this. And I forget my other P word on that.
Okay, thank you, David. Adrian?
Now, despite the doom and gloom, I do see hope in this room. Yeah, the chemistry professor feels that, you know, chemistry toxin should be addressed as the central of the circular economy. The environmental scientists felt that, you know, environmental science should be taught to every other school. The materials engineer tries to find solutions, you know, micro solutions to solving big problems. So there indeed hope in this room. And what I can gather is that if all of us take heart, you know, and put this big problem central to whatever things we do, you know, we can achieve the vision of the circular economy for a more sustainable world.
Now, activist Carol.
So I'm going to go back to this idea of a story. So remember that Aristotle actually came up with a description of what it takes to persuade other people. That's actually called rhetoric. And so to tell a good story, to persuade others of your ideas, you have to have logic. You have to put it into an ethical context, so you really connect. So it's logos, ethos, and pathos is the last part. So in telling an important story, we've got to get people to care. We have to care ourselves, and we have to find a way to help them connect. And with that, and it may take some experimentation, you know, think of this as being the, I don't know, the noble Cambridge Analytica. But how do we get people to care by using these concepts and coming up with the stories that help people connect?
Okay. Endocrine disruptor, Terry?
Well, I'd like to pick up on the finishing off on the culture aspect, because I've had the great privilege of seeing many human cultures, and I find them extraordinarily interesting. I think the differences are a strength, not a weakness, and I hope that we don't lose through homogenation the beautiful cultures that we have. I think sustainability could be the thing that increases the intercultural respect. I think it's the thing that we all know we have to have, that we all have to work on. And my guess is that it could be something, at least I hope and pray that it is something that can unite us together, reducing tensions between cultures rather than increasing tensions between cultures. And it really does require, as the Brundtland Commission, this is an incredible report. The Brundtland Commission people she was a genius, they were geniuses. It's a beautiful, beautiful document that we would be able to relate to each other peacefully and productively on these great issues of sustainability.
Okay, Mineral Mine, Brajendra.
So I will respond to Rajiv's point here. You know, this question came up very recently in one of the group meetings I was having as to what is culture actually. You know, whether before we talk about the cultural aspects, really what it came down to is culture is your ability to do the right thing when nobody is looking. That calls for consciousness, that calls for conscience, and that includes, you know, we just was asked, well, how do we educate the masses? How do we tell everyone? We have one person on one side, we've got 20 other candidates right now talking in United States. Each one of them is saying that we have a crisis with the climate, we have a climate change issue. 1/3 billion people are listening to all these people. Is it that difficult to decide, to understand what is being said? But still, you know, there's a good part of the country believes that, the history will repeat in a year and a half. So, that's what it is. It's our consciousness. We can easily, understand what is right from wrong, and that is what defines our culture.
Okay, education thought leader Ashley.
So climate change is the quintessential adaptive challenge of our time. It's not something that leaders, even all leaders of the world coming together onto the same page, can simply dictate an answer for. It really is going to require that all of the people of the world from the ground up find new approaches and solutions and all take part in this together. And I wonder, I don't know the answer to this, but something I think about quite often is how can we frame this, and would it make a difference to, instead of talking about crisis and panic so much, which I think can cause people to freeze and not really know what to do, is there a way we can instead use this as a moment of inspiration? And I think in particular about the 1960s in the US and the space race. The idea of setting this goal that within this decade we're going to go to the moon, and really bringing everyone together around this really inspirational goal. So if we could frame the sustainable world that we want as an inspirational goal, instead of talking as much about the crisis of climate change, would that make a difference?
Thank you. Storyteller Martin.
All right, well, we did talk about education a lot, so I think I'll make 3 quick points about education. First, formal education, I would definitely encourage to include systems innovation, and that includes also stakeholder management and systems innovation, systems dynamics, systems thinking, whatever your preferred term is, not necessarily only in a mechanical way, because it does come from the engineering, but think about ecosystems, forests, and how would cities look like that work as forests, create no waste, right? Try to be more interdisciplinary in the application of systems thinking, and of course, how to measure circularity and environmental impact. For example, do you know what your own carbon impact for the last year was? If not, then find out yourself how you are impacting the environment. Maybe you could even compare the car driving versus the flights you take, for example, right? So that's applied learning. You're learning by looking at what you do yourself, right? Secondly, that is basically my second point. Don't trust only formal education. Collaboration is key, because if you bring business together with scientists, if you bring, I don't know, kindergarten children together with politicians, then you'll get these kind of very, very creative and more fruitful thinking patterns and mindset changes. Like, for example, Greta Thunberg and Fridays for Future climate activists are showing us, right? And they are saying, basically, just listen to the scientists. That's what they are saying. We're not scientists, but they bring a new way in there, right? And last, just as a call to practical action, I think you should talk about the solutions you apply yourself. For example, my company, I made a commitment. My company will offset all the flights for this year. That's a very, very imperfect solution, but it's definitely a lot better than not doing anything. Maybe your institutions or individually you could do something similar. Secondly, check out the browser Ecosia. Every time you use it, instead of Google, you actually plant trees. Try that. And thirdly, think about who are the next 3 people you want to talk about the best thing or the most inspiring thing you learned at this conference. It doesn't matter who it is. It could be a colleague, it could be family, it could be your children, but just think about and make a commitment who are the next 3 people you're going to talk to. So just, try to get out of the formal education mindset. It has to be a collaborative effort, and what can you do for that?
Thank you, Martin. So I think we have a wonderful panel session. At this note, before I summarize, I'd like to invite my co-chair, equally passionate Professor Sudipta Seal, to take the chair specially set aside for him. Okay. Right, so I think what we will do is I will summarize in a very short way, and then he will also summarize in his own way. And after that, I think we will close the session. So there's a lot has been discussed, a lot has been asked. My pragmatic way, because as a Singaporean, everything has to be reduced to pragmatic things. So I basically take it as a summary, top line summary is, in education, we need to bring in systems thinking, a lot more as multidisciplinary approach towards sustainability, circular economy in our curriculum. And in terms of the business, social practice, and general life, I think we need a framework. We also need a clear metrics for measuring circularity, so that that would serve as a useful tool for businesses, societies, cities, as well as individuals. So I think these are the things we would need to do or share as we go along into the future. Sudipta?
Well, first of all, I'd like to thank the panel and, of course, the audience to have a very wonderful participation. And I think something Carol said, that what individually I can or we can do to start this conversation process. I was just playing with my laptop. I got to teach a class this semester on a brand new undergraduate lab. It's a team teaching class. So my module was on electrodeposition of materials. But I never thought about, I had my slides ready, I have a module to go, what they're going to experiment on. So I'm integrating sustainable chemicals and sustainable processes for this particular lab so that the student can understand. This is something I just took on for this semester. So I think each one of you can think of something else and integrate in your process. I think that will be a huge impact, and I'm sure that'll be a great takeaway from this meeting for years to come. So with that note, thank you all.
We should take one panel photo.
Oh, sure.
And for your NSF. Can you take